Welcome to Reframing the Membrane, Crossing Boundaries, where we advocate for actionable solutions for improving overall mental health and wellness by examining the challenges and resources affecting people and access to care. Each episode takes listeners through lived experiences and evidence-based research, providing practical strategies to build resilience and advocate for mind, body, and spirit well-being. Thank you for joining us as we engage with the community, health professionals, advocates, and individuals sharing their experiences. Before we get started, the content of this production may be emotionally challenging. The production will aim to inform you in advance when potentially activating material will be filmed or discussed. Let's get started.
Hello, I'm your host Capri, and today we're diving into a crucial and rapidly evolving area of understanding: the neurobiology of psychological trauma and toxic stress. Over the past 2 decades, there's been an absolute explosion of research, scholarship, and practical applications in the field of psychological trauma. For social workers, educators, therapists, healthcare providers, community leaders, parents, and truly anyone working with or supporting people, it's a whirlwind, a constant stream of new information that needs to be integrated into how we understand human behavior, design services, and engage in our daily relationships. This growing knowledge has led to distinct yet interconnected approaches, trauma-informed care, and trauma-specific interventions. And it's exactly the kind of deep dive we love to do here on Reframing the Membrane. So, what's the difference and why does it matter to you? Let's break it down. Trauma-informed organizations or systems are those that fundamentally acknowledge how widespread traumatic events and adversity are in the lives of the people they serve, whether those are clients, students, patients, or even colleagues. They don't just know it, they act accordingly. This means developing policies, practices, and processes that integrate a deep understanding of traumatic stress. Think of it as a universal precaution, much like in healthcare, where you assume everyone could carry a contagious illness and take appropriate measures. Here, we assume anyone you encounter could have a history of trauma, and you design your environment and your interactions to minimize the reactivation of their trauma responses. This could be in a school classroom, a doctor's office waiting room, a community center, or even how a company approaches employee well-being. This reframe, this new way of seeing things, is core to what we discuss on Reframing the Membrane. In contrast, trauma-specific interventions are therapeutic models specifically designed to address impairments that stem directly from trauma. These are about promoting healing and recovery, often delivered by trained clinicians. They are often evidence-based, meaning they've been rigorously tested and are tailored to factors like the type of trauma, the individual's developmental stage, whether they're a child, youth, or adult, co-occurring disorders, or specific populations such as veterans, refugees, or survivors of intimate partner violence. These interventions might even incorporate culturally specific approaches, recognizing that healing is deeply intertwined with cultural context. While these are often clinical, understanding their goals helps everyone appreciate the deeper needs of individuals impacted by trauma. Now, what has really fueled this revolution in both trauma-informed approaches and trauma-specific interventions? The answer lies largely in the incredible advancements in our understanding of the neurobiological underpinnings of psychological trauma. This is where the science helps us understand why people react the way they do, and it's incredibly empowering for parents, teachers, managers, and anyone trying to connect more deeply, even if with oneself. It's truly about reframing the membrane itself, getting a clear picture of the biological mechanisms at play. So if you think back to the 90s, the United States Congress was at a point in time where they were kind of in the decade of the brain. And this period sparked countless research initiatives, and the findings that emerged profoundly changed how we understand the very organ at the center of our being, the brain. Innovations in neuroimaging technology like functional magnetic resonance imaging or fMRI have given neuroscientists an unprecedented window into brain growth and development. This new information, particularly around the brain's remarkable plasticity, which is its ability to change and adapt, has directly stimulated the development of improved medical and mental health treatments. So, neurobiological research has also shed new light on the age old nature versus nurture debate. It's led to an increased focus on the crucial importance of infant and early childhood caregiver attachments and how these experiences can influence lifelong physical and mental health. Leading experts in child development have asserted that the challenge before us is to capitalize on the capacity of the scientific revolution to stimulate creative ways of thinking about how to address a broader range of societal concerns, including education reform, workforce development, health equity and promotion, prevention of disease and disability, protection of children from the consequences of maltreatment and exploitation, and reduction in violent crime, and the alleviation of poverty. Now, that's a profound statement, isn't it? It speaks to the far reaching implications of understanding how trauma impacts us at a biological level. It's not just about therapy, it's about societal change. And this is precisely the kind of holistic perspective we explore on this podcast. So, today's discussion aims to equip you and other helping professionals, such as social workers, therapists, clinicians, educators, parents, policymakers, and indeed anyone interested in human well being, with neurobiological information about toxic stress that can be integrated into policy, practice, advocacy, and even daily interactions. So, this knowledge, coupled with an understanding of effect regulation, how we manage our emotions, provides a powerful framework for developing and delivering services, fostering supportive environments, and simply understanding those suffering a range of consequences from adversity. So, we'll start by defining toxic stress as an expansion of the concept of traumatic stress. When we talk about potentially traumatizing events, the list is sadly extensive, ranging from intimate partner violence to child abuse and neglect, combat, natural disasters, terrorism, geographic displacement. These are just a few examples. Knowing the array of events that can produce psychological trauma can help policymakers and administrators and providers advocate for prevention, trauma-informed, and trauma-specific services in our communities. For individuals, recognizing these potential stressors helps build empathy and understanding. However, identifying and assessing the psychological effects of trauma exposure on individuals, families, and communities is far more complex. So many variables come into play: the type of trauma, the age of exposure, the duration of the events, relational factors, prior trauma exposure, social, ecological conditions, and cultural beliefs. All of these make unique contributions to an individual's biopsychosocial experience of trauma. Traditionally, psychological trauma has been most commonly linked to traumatic stress and the diagnosis of post-traumatic stress disorder, or commonly known as PTSD. Once primarily the domain of the Diagnostic and Statistical Manual, or the DSM, and psychotherapy, references to PTSD are now common in media and social conversations. However, since its inception as a diagnosis in the 80s, the conceptualization of PTSD has been criticized as being too restrictive. Practitioners working with children in particular have advocated for the inclusion of a developmental trauma disorder. And this advocacy has been fueled in part by neuroscience research that simply wasn't available when PTSD was first conceptualized. This ongoing evolution and understanding helps us move beyond simple labels and toward more nuanced support, a true reframing of our approach. So this brings us to a crucial concept that expands our understanding beyond just traumatic stress, toxic stress. Bringing together neuroscience, epidemiology, developmental psychology, and ecology, The Center on the Developing Child at Harvard University proposed a biodevelopmental framework that highlights the significance of the mind-body stress response system and the concept of toxic stress. So what exactly is toxic stress? It refers to a strong, frequent, and/or prolonged activation of the body's stress response system in the absence of buffering protection of stable adult support. So think about that for a moment. It's not just the stressor itself, but the lack of protective factors that makes it toxic. Major risk factors include extreme poverty, recurrent physical and or emotional abuse, chronic neglect, severe maternal depression, parental substance abuse, and family violence. The defining characteristic of toxic stress is that it disrupts brain architecture, adversely affects other organs, and leads to stress management systems that establish a lower threshold for responsiveness that is persistent throughout life. This increases the risk of stress-related disease or disorder, as well as cognitive impairment well into adulthood. In contrast to traumatic stress, toxic stress is a more inclusive concept that comprehensively acknowledges the intersection between biology, our genetics, and environmental conditions, as well as the lifelong consequences of a child's stress response system being relentlessly activated. We're even beginning to understand epigenetic adaptation, the process by which an individual's environment shapes gene architecture and expression, even influencing succeeding generations. Simply stated, adversity can become biologically embedded and create developmental vulnerabilities that can last for generations. This expanded perspective on the chronic stress of adversity is absolutely crucial for the development of trauma-informed service delivery systems, especially prevention and early intervention programs. It highlights why systemic change and early support are so vital. You can learn more about tracing trauma across generations and the introduction of epigenetics in episode 2 of this podcast. So we've introduced the powerful concept of toxic stress, and now we'll dive a little deeper into the brain itself and understand which structures are most impacted by adverse experiences. Understanding the basic brain functions help us to respond more effectively when someone is struggling, even if it's ourselves. More in a minute.
Are you ready to make a difference in your community? In our Speak Out Advocacy series, we're here to empower you to use your voice for change. Whether improving access to mental health care, reducing stigma, or shaping important social policies, this series provides the tools to create a lasting impact. If advocating for better care, breaking down barriers, or transforming mental health services speaks to your heart, this is the perfect space to learn and take action. Do you have a topic you're passionate about or need support advocating for yourself or others? We'd love to hear from you. Text the show to share your thoughts. Just check the details in the show notes. Together, let's build a community that fosters change. Keep enjoying Reframing the Membrane.
While a full neuroanatomy lesson is beyond our scope for today, understanding a few key areas will give you a profound appreciation for how trauma shapes the mind and body. We'll be discussing hemispheric specialization, the amygdala, the hippocampus, the hypothalamus, and the pituitary, and the medial, prefrontal, and anterior cingulate cortices. There are two halves of our brain, often referred to as the right hemisphere and left hemisphere in simple terms. They look similar, but their functions and processing are distinct. The right hemisphere is dominant at birth and remains primary for the first 3 years of life, focusing on survival, attachment patterns, emotional regulation, and sensory experiences. It's our relational hemisphere, mapping the emotional terrain of our earliest attachment experiences. These early imprints or internal working models of self and the world serve as signposts for safety and either promote or inhibit our exploration of the world. Think about how infants primarily communicate through cries, facial expressions, and body language. That's the right hemisphere at work. The left hemisphere develops more slowly and tends to be more logical, analytical, and sequential. It focuses on details to construct complex theories and narratives. It's often called the interpreter because it seeks explanations for internal and external events to produce appropriate responses. This is where our ability to tell stories, make sense of events, and plan comes from. Both hemispheres contribute uniquely to communication. While the left hemisphere is primary for language in the traditional sense, the right hemisphere is crucial for understanding emotion based nonverbal cues like body language and facial expressions. Meaning making, how we interpret our worlds, is a collaborative effort. The right hemisphere is dominant for emotions and relationships, while the left specializes in providing context and perspective, giving a narrative to emotional experiences. Individuals with traumatic histories, especially early childhood experiences, are more likely to develop a worldview of self as bad and others as dangerous, filtering relationships and experiences through this deeply ingrained lens. Recognizing this can help us understand why logical arguments sometimes fall flat when someone is emotionally activated. Now, the amygdala is a small almond shaped area that acts as a first responder. It processes input from all of our sensory systems touch, sight, smell, sound, taste to determine whether incoming information is life sustaining or life threatening. The amygdala automatically coordinates with brain areas involved in long term memory, which is the hippocampus, and inhibitory control, or the prefrontal cortex. If warranted, it participates in initiating a survival based response. All sensory input associated with danger is encoded by the amygdala as a threat to survival and is formed into memory. Before language develops, these memories are automatic and outside of conscious awareness. These are called implicit memories. They don't contain autobiographical or chronological references, so they lack a sense of self, time, or place and cannot be voluntarily recalled. Implicit memory encoding continues throughout life and is fundamental to encoding traumatic experiences. The amygdala, along with these implicit memory processes, builds a database of all information associated with threat. This database is then used to anticipate and respond to danger, both actual and perceived. This explains why certain smells or sounds can instantly activate a strong emotional reaction, even if we don't consciously know why. Closely linked to the amygdala is the hippocampus, which is critical for learning and long term memory processing. The explicit type of memory processed by the hippocampus differs from implicit memory. Explicit memories can be voluntarily recalled and explained using language. They are factual details of people, places, and events, giving them a sense of self, time, and place. Together, the amygdala and hippocampus contribute to the rich, detailed autobiographical story of our lives. They link the emotional and contextual aspects of events. So think of the hippocampus as your brain's meticulous archivist storing the who, what, when, and where of your experiences. Moving on, we have the hypothalamus and pituitary gland. The hypothalamus is located above the roof of the mouth and it coordinates our behavioral responses to maintain bodily homeostasis, the constancy of our internal environment. It works to maintain life essential functions like blood pressure, body temperature, thirst, and hunger. While much of this activity engages our reset and digest system, under threatening conditions, the hypothalamus coordinates with the brainstem and the pituitary gland to initiate the body's stress response system, preparing us for fight, flight, or freeze. The pituitary, often called the master gland, acts as the mouthpiece through which the hypothalamus communicates with the body, releasing a cascade of stress hormones when activated. This is the system that prepares your body to either face a threat or run from it. Finally, we have the medial prefrontal cortex, or the MPFC, and anterior cingulate cortex, the ACC. The brain areas we've discussed so far often act reflexively and subconsciously, what we call bottom up processing, but areas in the frontal lobe like the MPFC and ACC are involved in top down processing. This is slower, more deliberate processing. These areas filter reactions, inhibit responses, regulate emotions, engage in problem solving, direct attention, make plans, and integrate information. In a threatening situation, the MPFC and ACC help interpret the threat, evaluate emotional conflict, and even distract from fearful stimuli. They also monitor bodily changes like increased heart rate or breathing, an insight known as interoceptive awareness. After interpreting the situation, these frontal lobe areas may either promote a stress response or quiet down reactive areas like the amygdala and hypothalamus. But here's the critical point. When threat is consistently present or the perception of danger is sensitized, bottom up processing becomes normative. The involvement of the frontal lobe in threat assessment is bypassed and emotional regulation becomes impaired. This means that in chronic stress, our thinking brain takes a backseat and our survival brain takes over, making it harder to calm down or think clearly. So, how do all these parts work together in times of threat? Through a complex system of neural networks, these brain regions continuously process physiological and affective arousal to maintain a state of regulation. When the brain interprets stimuli or experience as life threatening, there is an automatic subconscious activation of survival strategies, most commonly fight, flight, or freeze responses. Accompanying this physiological activation is the intense, affective experience of fear. This innate initiation of survival strategies is based on both genetically encoded ancestral memories of past dangers and what an individual's neurobiology has learned about threat in current environments. This ongoing cataloging of threat stimuli is a prime example of the nature nurture interaction, also known as fear conditioning. Typically, once a threat has been averted or the amygdala's perception of threat is determined to be non threatening by the hippocampus, the stress response system shuts off and regulation is restored. However, when the threat is frequent or prolonged, the brain's ability to regulate becomes impaired. Deficits or alterations in these stress regulatory processes are at the root of many mental health impairments, including post traumatic stress and complex trauma disorders. Recent research, most prominently, have shown that there's a clear link between early childhood adversity and adult health problems, including cardiovascular and immune diseases. So it's becoming clear that anyone working with individuals who have a history of trauma exposure are indeed working with altered stress regulatory systems. So, when danger is detected, multiple distinct systems are activated to respond to real or perceived threat, initiating fight, flight, or freeze behaviors. And during activation, the brain prioritizes resources for survival essential activities like heart rate, blood pressure, and muscle tension, while decreasing activities like digestion and higher cognitive functions. The SAM system is quick acting, releasing adrenaline. So think of this as your immediate burst of energy when you're startled. Comparatively, the HPA system is slower, exerting more prolonged effects, including those associated with toxic stress. And the HPA system that I mentioned is the hypothalamic pituitary adrenal system, and the SAM system that I mentioned is the sympathetic adrenal medullary system. Both respond to real or perceived threat, initiating fight, flight, or freeze behaviors. And during activation, the brain prioritizes resources for survival essential activities like heart rate, blood pressure, and muscle tension, while decreasing activities like digestion and higher cognitive functions. The SAM system is quick acting, releasing adrenaline. Think of this as your immediate burst of energy when you're startled. The HPA system is slower, exerting more prolonged effects, including those associated with toxic stress. So, after the amygdala detects a threat, there is a release of hormones, and these various hormones are signaling the pituitary gland and prompting the adrenal gland to release cortisol. So, all types and levels of stress, whether it's physical, psychological, or emotional, can initiate a release of cortisol. While dysregulated cortisol levels can be problematic, an adequate amount of this hormone is necessary for motivating activity and, importantly, for turning off the stress response. When the stress system is continually activated by threat, the brain adapts by resetting its normal state to consistently fired up mode. This heightened, persistent level of stress response becomes toxic to the mind, body, and spirit. Cues associated with the threat, visual prompts, smells, ambient sounds, time of day, which ordinarily wouldn't cause a stress response, are automatically associated with the threat itself. So this information is stored in the amygdala's implicit memory file as a warning of potential harm. As a result, negative affect states like fear, shame, rage, numbing, or disassociation, and physical sensations like muscle tension, increased heart rate, or rapid breathing are easily activated by cues. even in seemingly non-threatening environments. This is why someone might become agitated in a crowded space, even if there is no obvious danger. So, toxic stress profoundly impairs the HPA system that we talked about and alters the structure and functioning of brain areas. Numerous studies have shown that the HPA system becomes highly sensitive and overreactive when exposed to unmitigated chronic stress, especially in developing brains. The hippocampus, in particular, is exceptionally vulnerable to these effects. So, chronic overactivation of the stress response system, flooding the brain with excess cortisol, impairs hippocampal dependent learning and memory processes. Excessive cortisol can even reduce the volume of the hippocampus and impact its function. When altered by toxic stress, the hippocampus has a significantly reduced capacity to provide crucial contextual information to the amygdala about what is truly dangerous and what is safe. Many individuals with PTSD, for example, show low baseline levels of cortisol, suggesting an exhausted HPA system, which may account for the intrusive memories they experience. The amygdala, working with the hippocampus and HPA system, also undergoes structural and functional changes due to toxic stress. Given its central role in relational processes and the development of attachment strategies, the amygdala is extremely sensitive to excessive activation in early life. Infants, children, and youth are particularly susceptible to toxic stress and impaired regulatory functioning in the prefrontal cortex and anterior cingulate cortex. Excessive activation in emotion responsive areas and underactivation in areas involved in cognitive processes of assessment and evaluation lead to developmental disruptions. This underscores why early childhood experiences are so foundational for lifelong well being. So, how does all this neurobiological information translate into the daily work of helping professionals, educators, parents, and anyone striving to create more supportive environments? It leads us to what we call the Neuro-Trauma lens. Learning from research findings about the neurobiological consequences of toxic stress provides all of us with a profound understanding of the effects that trauma exposure can have on individuals, families, and communities. While we still have much to learn about how toxic stress affects the brain, mind, and body, and how the social ecology promotes, inhibits, or exacerbates these effects, this knowledge is a powerful tool. Knowing how to infuse human service organizations, schools, workplaces, and even family dynamics with a trauma informed culture is an ongoing process. Such a transformation takes time and investment. The principle of universal precaution within trauma informed approaches is based on the high prevalence of trauma exposure, polytraumatization, post traumatic stress, and complex trauma among all people we encounter. The vast majority of individuals and families who seek help or with whom we interact have significant trauma exposure, compromised neurobiological functioning due to early trauma and ongoing adversity has often contributed to their challenges. Simply stated, implementing universal precaution means designing and delivering all aspects of services, interactions, and environments with an understanding of how trauma shapes neurobiology. It's not a model or a technique, it's a frame of reference. With the understanding that individuals may have compromised stress regulatory systems, the challenge becomes creating environments and interactions with the primary goal of maximizing everyone's experience of physical and emotional safety. In other words, service design and daily interactions are developed in such a manner as to minimize activating trauma based neurobiological response patterns. Individuals can only establish and utilize regulatory strategies within non threatening environments and relationships. Brain areas necessary for cognitive processing, new learning, and meaning making can only be assessed if emotional regulation is first established. Both social, ecological, and neuroregulatory intervention strategies are necessary for resilience and recovery. Organizational cultures, classroom practices, and even family dynamics that are trauma informed can create environments essential for initiating and maintaining neurobiological healing. Individuals with trauma anchored neurobiologies have exquisitely perceptive threat response systems. The slightest trauma reminder, a voice tone, a question, A closed room, even a specific smell, can set off a powerful cascade of somatic, emotional, and physical responses, which are often not within the person's conscious awareness or immediate control. Staff, teachers, parents, therapists, providers, and other clinicians may misunderstand these automatic hyperarousal or hypoarousal survival oriented reactions as manipulative, oppositional, hostile, uncooperative, withdrawn, or disinterested. Instead of asking, "What's wrong with you?" to behavior that is challenging or not understood, think about asking, "What's happened to you?" to begin to shape a trauma-informed response, a response rooted in empathy and understanding. This is the true power of reframing in our daily lives. To assist everyone in thinking and acting through the neuro-trauma lens, here are some guiding questions that you might consider. What changes can be made in the physical space of any setting, so home, office, classroom, community center, to increase the sense of safety for others? When I apply the principle of universal precaution, how does my approach to interactions or problem solving change? When I acknowledge that someone's behavior or effect might be serving a learned protective function, what changes in my response? How can understanding the functions of the brain's hemispheres help me better understand someone's state of mind and shape my response accordingly? For example, how do my verbal and nonverbal responses align with their emotional state? What do I know about the amygdala and the hippocampus that helps me observe when someone might be re experiencing trauma? And how can I intervene empathetically? What are some examples of behaviors, emotions, or relational capacities that might represent survival responses? So think flight, fight, freeze, in myself or others. What is my plan to learn more about the neurobiology of toxic stress and advocate for more trauma-informed approaches in my sphere of influence, whether that's my family, my workplace, or my community? These questions are designed to encourage a shift in perspective, moving from a deficit-based view to one that recognizes the profound impact of adversity on the brain and body. While the focus for today has primarily been on the individual's neurobiology and regulatory capacity, it's important to remember that trauma-informed approaches must also focus on the social ecology in which individuals live. Reduction of traumatic exposure is of equal importance. Knowledge about the enduring effects of adversity on mind, body, and spirit is also the basis for addressing social policies and prevention programs, and it helps us all advocate for a healthier, more supportive world. So, understanding toxic stress and the neurobiological underpinnings of trauma is not just about gaining knowledge, it's about transforming how we interact with and support those who have experienced adversity. It's about building a more compassionate, effective, and truly healing society, one that is informed, one interaction at a time. And that's what we strive for in every episode. So thank you for joining me today. I encourage you to reflect on these insights and consider how you can apply a neurotrauma lens in your own life and work. Until next time, take care.